So we're going to lesson 2 of Demystifying compilers, and we're going to talk about the Lexical Analyzer. So recapitulate what we saw in the previous lesson. We saw that the compilation process is formed by a lexical analysis where the individual words and symbols of the code, the lexemes, are mapped into tokens kept on a symbol table, and it is checked if either or not all of them are valid. A syntactic analysis where it is checked whether or not the sequence of tokens is correct. A semantic analysis where, beyond other issues, it is checked whether or not there is a consistency on the usage of type declarations and type expressions, and the code generation and optimization phase. So the overall process that we saw in the last lesson was we saw that the program code is input for the lexical analysis, and then the result goes to the syntactic analysis, and then to the semantic analysis, then to the code generation optimization, and then we reach the machine code, generated code. And on this lesson we will focus our lens on the step of the lexical analysis. So come with me and I'll teach you everything I know. We saw that each word and symbol of a code is mapped into tokens, and those that are names of variables or functions or methods are stored in a symbol table with their relevant information. But how does this process work? Let's come back to our old Java example that we saw on the previous lesson on the right. This is an example that performs a sum between two numbers and then outputs the result. So a possible partial mapping lexeme to token for the program on the right could be a public, lexeme public being mapped to token public, lexeme class being mapped to token class, lexeme dot being mapped to token dot, and so on for left brace, right brace, int, plus, and semicolon. One could think that the notation used before could be enough to specify the lexical analyzer, but in the case of variable names, numeric expressions, strings, and etc., we cannot predict their exact word. Scientists and scientists 2 are different lexemes for token string. 1 and 3, 4, 5 are different lexemes for token number, and so on. So in order to specify tokens for strings and numbers, for example, we need to use regular expressions, that is, expressions that represent possibilities of lexemes according to their properties. So A star represents 0 or more occurrences of A plus represents 1 or more occurrence of A question represents 0 or 1 occurrence of A or B star represents 0 or more occurrences of a word that's either A or B. A to Z represents 1 occurrence of a word that's between A and Z, and 0 to 9 represents 1 occurrence of a digit that is between 0 and 9. So the other tokens would be mapped such as shown here. So token number would be a digit from 0 to 9, at least one digit from 0 to 9 can be 1, 2, 3, 4, and so on. Token identifier has a mandatory letter that goes from A to Z, and then is followed by a 0 or more elements that can be either a letter and a digit, and then we have token string that is formed by a double dash in the beginning and a double dash in the end, and between these double dashes we would have 0 or more letters or digits. About the symbol table, it is a table that will store information that will be useful for the type checking on the step of semantic analysis. It is, however, mounted during the lexical analysis. It stores all variable names, their types, and their scopes. Scope is the space on the program in which the variable is accessible and visible. The information of the symbol table will be used by the semantic analyzer for type checking the source code. If there is some type error, for example, some name of a method being used as a variable name in an expression being assigned to an integer variable, the semantic analyzer can query the type of that name on the table. So a symbol table for the program on the right would be program below, sorry. We would have here the lexemes of the program, sum between numbers, main, args, x, y, z, and then scanner. their types, these words would be mapped to, would be stored, would have the type stored, class, void, string, array, int, and object scanner. The scope of both sum between numbers and main, these methods have a public scope. Then args is a parameter, and x, y, z are local variables declared inside the main method, as well as the scanner object. Okay, so let's do an exercise here. Mount the specification of a lexical analyzer for a subset of Java with respect to type declaration. Consider that the use types are int, float, double, and string. So, type declarations can be like int, x and y, or even like float, x, int y, string str, str2. So the possible tokens are int, float, double, string, column, semicolon, and ID. A mapping from lexemes to tokens for this example would be lexeme int being mapped to int, lexeme float being mapped to float, double to double, string to string, column to column, semicolon to semicolon, and then for IDs we would have this situation here: at least one letter, and then a sequence of 0 or more digits or letters. If we allow initializations with the assignment operator and expressions for integers, floats, doubles, and strings like this, we will also have the following maps for lexeme token. We would have str expression, we would have a mapping that would be the representation of a float and double, and then we would have also the lexeme assigned being mapped to token assigned. So where an str expression is a string expression and an FLD expression is a float or double expressions. In order to mount the symbol table, we need a specific example, so we'll consider this example here, this declaration of variables with their initializations. And the symbol table will encompass all names of declared variables. In our specific case, there are no methods or functions to be declared, and as a consequence, the only possible scope is public. So the scope of all the variables is public. Their types are here: float, int, string, string, and each lexeme x, y, z, str, and str2, we see that the lexemes types and their scopes that are all public. So in this lesson we learned how to specify the lexical analyzer of a compiler, as also mounting its symbol table in order to allow the type checking on the semantic analysis. And in the next lesson we will learn how to specify the syntactic analyzer of a programming language. Thank you very much. Subscribe to this channel, like this video, and push the little bell such that you receive notifications for my new videos, and make questions and suggestions on the comments.